Welcome everybody to Startup in the Month 1, Day 11. Wow. And, that's already not right. Okay, cool. Yeah, guys, so, yeah, really stoked I got the WebSocket thing to work yesterday. That was really nice. It was a long way to get there with a lot of, false steps and wrong turns and confusion and everything like that. But now that I've got the basic thing working, and now that I've had just another night to kind of sit around and think about it a little bit, doesn't seem so mysterious. I remember, oh geez, who was it? YouTube, Ruby on Rails guy. David Heinemeier Hansen. Boy, this David Heinemeier Hansen had a really good keynote. Writing software, but doesn't scale. Fix me. Yeah, here it is. This was a really good talk by David Heinemeier Hansen in 2018, and it's all about complexity in software development, basically. So the basic idea is that his argument is that the field of software development in general has become super complicated. And it's kind of going back and forth between these flows of on one side having libraries and frameworks which have a specific job to do, and they do them well, and they do them and they present the idea of what they do in such a way that they're very easy for laymen to pick up and just start running with. And that's really good because it makes software and programming and coding much easier to get into, and kind of removes the barriers to actually getting involved with it, or getting good at it, or just doing something with it, building a product. And so he definitely falls in that camp. He was the inventor of Ruby on Rails, and that's just a great framework for building out a web service, or starting to build a web service. It gives you templating and HTML and CSS in the back end, and database connections and user auth, and it's basically a one-stop shop kit for most things that you would want if you were going to build a certain type of web app. And then there's this one part in his talk where he goes into old battles, modern web applications. Yeah, WS Death Star, that was it. So he's got this term, WS Death Star, which he never really fully explains, but I can only assume that those are WebSockets he's referring to. So, anyway, he has a low view of that technology because it takes something that's very easy, which is, relatively easy. I mean, there's a learning curve associated with all of this, but compared to WebSockets, just normal web HTTP methods are super simple, right? I mean, you kind of compose a message, you get all your data together, and once your data is together and ready and all present, you send off the message, and then the server receives the message, and you just kind of go about your day, and you don't have to worry about things like race conditions, or when a message received, or whether a connection was established, or whether it was dropped, or whether it was reconnecting, and whether you sent a message in the middle of that, or attempted to send a message that wasn't received. So I was thinking about that because I'm pretty familiar with all that HTTP stuff, but for my first go around with WebSockets, I think I kind of experienced what he was talking about in terms of that increased complexity and that increased barrier to entry, and getting to the point where you can just actually do something and start being productive with it. Although I think the issue is that just really just move this all into my root directory, right? Why do I need to keep them documents? When you get down to it, what you end up with, or at least what I think I'm going to end up with, is something kind of similar to handlers. Yeah, here we go. So this is my super dirty, commented out, work in progress WebSocket event message handler thing. But yeah, exactly the place I got hung up with this was just like setting up the connection in the first place, right? Like that first day I was trying to just integrate into my server, which was like a huge kerfuffle, and then I was trying to like, do something custom with it, and that was a huge kerfuffle. But really, I think what it boils down to is like something that's very similar to the like HTTP message equivalent that it's sitting on top of, where you've got these like IDs, and you've got something you do when you receive a message on that like ID channel, if you want to say that. So yeah, I think once you get over that hurdle of like actually integrating it and getting it running on the client side and the server side, it becomes a game of like, okay, so someone connected to me and they opened a WebSocket channel on my server. What do I do then? Someone pinged me with their connection. Like, what do I do with that? Someone wants to register the game. What do I do with that information? And what data has come along like on that route? So yeah, I think if you could just like take all this router stuff, all this like server, well, there's actually not all that much in here, but all this socket stuff, stop the router, start the router, configure the thing, start the server. If you could just like take this synth library and kind of wrap it up like one more layer of abstraction where you just like drop it in. It does all the things that it needs to do and provides some like sensible defaults for those things. You can actually like make this a lot easier, I think. But yeah, if I ever get to the closure like open source scene, that might be something I do. So there's a lot of good example repos associated with Sent. Like if you go to the docs, I've been here quite a lot in the past couple weeks. If you go to example, yeah, this like example projects area. So there's all kinds of like real good example repos with varying degrees of complexity, from like very simple like here's just the basic WebSocket stuff you're on your own to like, hey, I built a whole like snake game, or I built a whole blackjack game. And if you want to see how something that's more complex is built, that's how you do it. But if you could take the stuff in here and just wrap it up into something that's like easier than all this, something you can install via a jar or a library or something like that, then I think you can make it a lot easier. So anyway, just some idle philosophizing and reflection this morning for you. But anyway, let's get into the game plan, since we're here to make something, aren't we? Yeah, the plan today is to program some game logic finally. So it'd be kind of funny that, now that we've got the WebSockets going, that I'm kind of like stepping back from that again and like getting into more of the straight closure stuff. But I think now that I've gotten the WebSockets figured out, and now that I have like a basic idea of how the communication between client and the server is going to go, we can get back into that domain of like just like writing functions, right? Like writing pure functions that take data in and give data out, and all the like state manipulation and tracking of things that's associated with that. So that's a lot easier, and I think that's a better thing to do kind of in like a sandbox environment, as opposed to like hooking it up to the WebSockets like straight away. So I want to do that. And I also want to do that from the perspective of getting comfortable with REPL-driven development. So this is one of like the main things. And actually I had someone in the chat yesterday who was asking about this, who I think had not been exposed to the Clojure language before. Someone named Potato Mage, which is just a fantastic internet handle. Anyway, this language is supposed to be something that's like revolving around the REPL. So it's where you run your programs. It's where you run functions. It's where you stop and start servers, and it's also where you can make changes in the code, run the code, inspect the code, and like just see what's going on. So I've had a flavor of this with JavaScript. So if you go into the browser, you've got like the console, which is kind of like, got like REPL-ish things. Like you can do like JavaScript in here, or you can like write a function like const demo func a plus b. Why does everyone go to why does everyone go to addition and subtraction when they do these things? I don't know. It's just like a convention you pick up along the way, I guess. But anyway, you've got like some of that in the browser console environment, but it's like, that times 1,000 for Clojure. So that's one of the main benefits of the language. It's one of the reasons why I'm like, trying to learn this language, because I think it can make me a lot more productive and make just working with the code a lot nicer. So this presents a really nice opportunity to start getting comfortable with the REPL and experiment and kind of learn the way to just do that in general. And specifically what I wanted to do this morning is take advantage of some super sweet techniques I learned about. So I figured in the afternoon I would take a little while to do some like internet sleuthing just to figure out how to use the REPL effectively. And I came across these two articles. One of them is The Power of Clojure Debugging, which had a lot of good stuff. And then that article makes reference to this article, REPL Debugging, no stack trace required. And there's a really cool thing in here, which is actually one thing I've been wondering about as I've like kind of gotten deeper into the language and like started using it for real. And that is like how to debug a function that takes arguments. So we've got this like foo function here. It takes an n argument, and you can like run the function, you can pass it arguments, but eventually you get to a point where you've got some kind of like really complicated object you're passing in, map, I guess I should say map. You got some complicated map you're passing in, you got some big vector you're passing in, and that vector is passed to that function by another function, which had it passed to it by another function, and so on and so forth. And so like how would you use the REPL to debug that if like, the only chance you have to see in operating is like when the function is called for real in the function or functions that call it in turn. And this guy's technique, I can use his name right, Stuart's technique, Stuart Holloway, I can also increase the font size, can't I? Is to actually take those like function arguments and define them as global variables. So this is like super interesting to me, especially coming from like a JavaScript environment, because it seems like really simple, but like really kind of some term for like a beautiful idea. Blanking on it right now, but if you just define this as like a global variable, assuming that variable is like defined nowhere else in your program, then you can load this code into the REPL and call that function with that variable. This might be a good thing to demonstrate right now, actually. Let's go to this debug file. So let's say like defn string, other string. Right, what is this going to do? It's going to call like string with a string with the string and the other strings. A lame function. Combine strings. This is supremely silly, but anyway, just for the sake of demonstration. So say we have like this function like choose choose strings, or do the thing. And that takes a word list. And so, wait a minute, we can go back to what I was working on yesterday. Get ran titles, take and shuffle keys movies. Here we go. That's the function I'm looking for. That'll come up later. You didn't see that? Okay. So this will take 2 words from the word list and just like return them to them. So say our def word list is a vector with like a and e, closure is neat. Alright, and let's put a space in between because of course we're going to need that. Right, and that's going to take, right, so that's going to say apply combine strings to the result of taking 2 from this random shuffling of the word list. So let's load this into the REPL. Oop. What's going on, man? Oh wait, I got the wrong keystroke. There we go. No such namespace string. Oh. Stern, other stern. It's just a bunch of throwaway code. I won't. Man, do I need to require the string module? Closure string, namespace. Closure.string is string. There we go. Okay, cool. Now we're done. So yeah, if we call do the thing with the word list is closure, and then if we do that again, Andy closure, closure Andy. Neat. Hey. Yeah, so we're doing some kind of silly things here, but say we had like something really weird, like nested a nested vector. So if we load that back in and we start to run this thing and we wait for the nested vector to come up. Here we go. Okay, so now we're getting some like weird stuff, right? Because like our word lists had not only strings but also a vector of strings, and now we're getting something we obviously don't want. So what we can do, since this function calls this function and it took an argument, which is like, you know, processed by some like other code and passed to this function, what we can do is we can say like def stern hey, look at this. Then we can say def other string. So now we define the arguments to this function as global variables, and if we load this in and say combine strings stern other stern, we can like yeah, take those like specific cases, run them through this function, debug them, and also evaluate them inline. So yeah, anyway, that's the debugging technique. That's something I want to get more comfortable with and use, because that's like obviously a really good way to inspect the operation of my program, and I think it's going to be really helpful for me as I you know, develop this thing out and kind of discover all the things I need to know along the way. So anyway, that's what we're going to be doing. Our mantra for this morning is KISS, so keep it simple, stupid. And that is because, yeah, I was kind of getting into like the game logic programming thing yesterday and getting a little nervous about it because I was kind of realizing like how much stuff is going to go into it, just in terms of like data and like things to track and users and game IDs and user IDs and things like that. And I was getting a little bit wound up, but I think if I focus on keeping things like as simple as possible for as long as possible, then that will make it a lot easier to do, since I can get like really super deep down the road in a particular implementation without like tinkering with it and like kind of poking at it. I might end up with like this big complicated mess that I have to delete half of after the fact. But if I keep it simple, start small, go slow, then it'll all be good. All right. So all that being said, we're going to take the starter game logic code and build it out further. And the whole idea is that we're going to be building out functions which are easy to integrate with our existing WebSocket connections. But before we do that, I want to do some promotion. Twitch. Just a quick post. Slack channel. Oh, we're up to 15. Very nice. Hey everybody. The first half of your week has gone well. Streaming again this morning until 12 o'clock EST or thereabouts. Today's stream will definitely be very closure focused. We're starting in on the game logic for Potters for Real. Let you know, since some days end up being a bunch of pickup templates and or streaming this morning until 12 o'clock. The stream will be very closure focused. Cool. Alright, we got that out of the way. I'm going to close that so we don't get distracted. Anyway, I've also been thinking links. I should start keeping track of the stuff I reference. I don't know what I'm going to do with it, but it's good to have it. Cool. All right. So let's quit something that wasn't Slack earlier. Oop. All right. Coding game logic for plotters. Great. Man, so much nicer to keep that in a text file as opposed to customizing it in OBS. Much that I love this program. It's like super freaking sweet. Yeah, so anyway, let's get into it, shall we? Right, so I've got this thing called like state cljs. I don't really know what I'm doing with my organizational scheme here, and I don't think I'm quite at this point yet, much like I wasn't quite at the point. Wasn't quite at the point that I needed to reframe. State management. Yeah, so this is like like a state library, like a React-ish like state library for the backend called component. And this is to kind of like keep your state under control and, you know, keep things from like getting too crazy or too messy or too incomprehensible. So, yeah, I think if I'm ever building out something like real intense, I might want to start looking into this because, yeah, backend state is like something. I've got like exposure to those ideas from the front end, but I've never really like written a stateful backend app before. Like I've basically written APIs that like read and write to databases. So this is like a first for me, like writing game logic on a back end that interacts with like multiple clients as opposed to you know, something that's purely front end based. So I might want to get into this eventually, but for now I'm just going to use our good old closure atom because yeah, that's where I'm at right now. I don't want to like take the plunge like too quickly. Because that just leads to heartache and broken hearts or something. Great, let's close all this. Let's close that. Let's get back to just some basic stuff. And let's get loose, right? Let's get loose. Let's get okay. All right. Don't even want that. Okay, so wow, where to start? I guess I was starting here with like registering the game. So this is, it'd be really helpful to have those like hiccup templates open, but I don't think I want to spend the time getting that thing running again since I've kind of broken it recently. But anyway, the whole cycle of things is that you got a set of players who are interested in playing the game, and you've got like a host. So the host starts the game, you get a random four-letter code which like represents the game you want to join. So the host starts a game, and then they get like a random 4 letters back, like FRND or something. So they register the game, and the whole idea is that game ID is going to go into like our game state, and it's going to become a map with these things associated with it. So it's going to have the game ID, it's going to have a list of players, it's going to have a list of plots for the game, it's going to track the round and the points and all this stuff, and I'm already way too deep into that. So anyway, that's what we're building. But the first thing we need to do is like just start with the really basic stuff. So I'm even just going to comment this out, because I think that is even too much already. And I'll just like start this thing anew. Yeah, okay. Loose agenda. Yeah, let's just like real slow, just like identify our requirements and get to it. Okay, so step 1, build game creation code. Okay, so what do we need? Random 4-letter game code. And we need a starter object to feed into game state. And should I get so far out onto the limb as running through the whole process and updating the states? Save the starter game object into state. Alright. Magic number 3. Our puny human brains can't really handle much more than that, so that's a good place to start. Alright, so random set of characters closure. Not proud. Not proud. No pride. Random sample. Okay. Generate character sequence. Closure data generators. Sounds super cool, but a little too intense for what we're trying to do here. Generate character sequence from A to Z. Not really what we want. Ooh, repeatedly. Random string. Okay, let's read this. Oh, is this exactly the function we need? I think it is. Does it have one, too few parentheses? Yes, it does. Yeah, man, like, rand stir 3. Oh, perfect. Oh, perfect. Rand stir 4. Oh, perfect. So fast. Yeah, so anyway, should we go through an exercise just to see what's going on here? Char repeatedly 65 times. Yeah, so this like gets generates like characters from like 0 to 26, so I guess there's like character codes associated with that. Add 65, so that gives us like a character code, like 2 plus 65 would be like the character B. We do that repeatedly, and then we take the length, so we take 4 from that, and then we combine them into a string. So repeatedly is like a lazy evaluation thing, and Clojure is smart enough where it says like, okay, take 4 of these things from like this infinite loop of just like generating random strings, like one after the other, but only give me 4 of them, and then it'll stop. And then once we've got that vector of strings, we apply the string function to them, combine them into one, and then we get LNPC. So man, that's perfect. That is perfect. But do we want to leave it like that? Do we want to hard code to 4? I guess it's okay to keep it at 4, or keep it as a function, right? All right, get game code. Perfect. We are already done. Done. Thumbs up. No shame. Eurus80 says, what's the 65 again? Hey, you know what? I'm trying to get better at the REPL, so let's go into the REPL and check this out. Okay, so we've got this char function. Do we get a thing? Yes, this takes like an X and coerces it into a character. Never mind, lol. Okay, cool. Yeah, so anyway, you know, but just for the sake of me learning what this thing actually does, so if we did like char, what'd I say, 26 plus 2, I think this is going to be a B. Oh. Slash plus random, 65. Yeah, so if we did this plus 65, I think that's a B character. Or something. Anyway, yeah, you know what that does. I think I know what that does. I don't really have a super clear understanding, but anyway, that gets a character code from a number, and that's what we're using for our game code. All right, cool. Yeah. So what next? Starter object to feed into game state. All right. So yeah, let's have a starter object. Define make starter objects, and so far this function just has game code. And what it's going to do is give us back an object, the game code corresponding to the game code. Alright, load into the REPL. Make starter object ABC. Yep, cool. Game code ABC. Alright, so we're done with that. Alright, save the starter game into object. Save the starter game object into state. Alright. So this kind of implies this create game function, which we had from before, but we deleted. You know, working in a real small kind of context here, so let's make the font a little bigger. Alright, so yeah, let's get into this create game thing. So defn create game. And then we have like a def state as an atom. Starts with an empty map. Alright. Yeah, I could get into like a bunch of let block stuff here, but I think just for the sake of keeping things simple as we're attempting to do here, we can just say make starter object, and we'll feed it. Let's get a better name, right? Make game state starter, and we'll feed to this get game code with a length of 4. Alright. So we load that into the REPL. We call it create game. We find out what our state is. Oh. At state, def state. Really, it's game state. And we also didn't set it, so that's what we need to do next. All right. Right. So that is going to be a process of resetting. Secretly, we know we're going to have more than one game, right? So instead of resetting, I think I should swap. So swap. Swap. Let's go back to the docs. Swap, closure core. Alright. Swap the players. Conj player 1. Can join a second keyword into the list. I think what I'm looking for is a soch. Yeah, so soch means take an object, add these keys and values to it, right? So soch the, do I need that at thing? I don't need the at thing. Soch game state with the result of calling the game starter function with a game code. All right. Load that into the REPL. Create game. Nope. Have bug. Inspect bug. Line 38. You can't cast that thing. Swap game state. Like that. But then I think I need to create game, wrong number of args to pass to the thing. Alright. So I think what I need to do is I need to like put this in a function. Soch, whatever the argument is that we passed into this, with the result, insufficient input. Ah, man, it's supposed to be like easy function day. Oh, got all kinds of errors I did not expect to have. But will it chooch? Type mismatch. Swap the game state. Use this function to do it. Okay, this is a good time to practice those things I was talking about. This like REPL-driven stuff that I'm trying to get better at. Okay. So I think the problem is that right, okay, I don't have a key for this, right? Yeah, so I think I do need a let block actually. So let's let game code be the result of calling this function. And I think we want to turn into a key too, right? Like turn string into key closure keyword. Yeah, that's what we want. Keyword. Keyword. Yeah, so we need this both in like key form and string form. So we can say like keyword game code game state starter. Into this we will also pass the game code. I think that's what we want. So let's try calling this one more time. Ooh, look at that. Look at that shit. I shouldn't curse. Game state. At game state. What am I doing wrong here? I'm trying to like read the value of this atom, but it's giving me print line at game state. Right. Yeah, that's exactly what we want, right? Cool, so we've got like a key in our map, which is the game code, and then we have our super simple like starter map, which consists of a key called game code and the game code string itself. And something to look up later is why I can't do that. So this is another thing I'm trying to like figure out is closure atoms and dereferencing, and coming from a like language like JavaScript where like all this kind of stuff is happening like underneath the covers. I don't really have like the proper context to really understand what's going on here, but with an atom you can like dereference the state of that atom with this little @ symbol, and that, as I understand it loosely, is a process of like saying like, okay, at this point in the program when it's executing, give me the value of this like mutable thing at that time. I think that's also a way where you don't like accidentally overwrite it or something. I'm not really sure, but yeah, I don't really understand why I couldn't just do that in the REPL. Like I could print line the game state and like dereference it and get it fine, but if I tried to just like put in parens and say like add game state, it's giving me this it's giving me this weird thing. Well, I know I've got this harebrained idea to start quoting things. That's also another closure-ish thing. Man, I'm just belying how little I really understand about the internals of this thing. Yeah. Anyway, let's not goof around with that too much. I will come to an understanding of it in due time. Probably when I experience bugs associated with state and trying to access it. Okay, cool. So yeah, let's go back to our thing. Save the starter game object in the state. We're done. Great. Okay. Another thing, format current form. Not really sure if is conventions for like white space and tabbing and formatting. Is that like one line thing? Is just like really hard for me to read. I don't know if that's like a closure convention to keep things on like one line until a certain point, but yeah, something for me to learn. Okay. Cool. All right, what do we need to do next? We need to add the host as a player into the game state. Add the host of the game as a player into the game state. It's like a host starts a game. They get a random code, and then once they get that random code, the host can like send out that code to the other players, saying like, "Hey, I started a game, and it's in NBMR or whatever." So they send that out, but it's kind of silly to have to like join the game after creating the game. So it'd be good to have them just like in the game automatically after they create it. Great. Cool. Yeah, so that kind of implies like a player, right? Let's just say like def host equals not the syntax. Def host equals Andy. Host is me. All right. So when I create the game, we're gonna pass it the host. All right, and we're going to associate in the game state the game state starter. So I think we need a game code, and we also need a host. Game code and a host. The game code is the game code, the host is the host. Load that in, run that function, create game. Oh. Right. Create game using the host. Great. Game code GB, host is Andy. Done. I think we're going to be coming back here a lot, but that is great. It's quick little on software. Closure debugging 1. Closure debugging. Great. Okay, add the host of the game. Right, okay, now we're done with that. So we got the game code, we got the host, and now what we need is a set of movies. Okay, so secretly, yesterday, I already made this. So we're going to copy this down here. We're going to take a look at it, and we're going to figure out A, if we want to keep this, or B, if we want to do something different with it. So and I've got yet another map, and now we've got a few things going on. We've got the title of the movie here, and then we've got the description. So our favorite movie, The 39 Steps, The Aviator, Ghostbusters. These are like obviously very well-known movie titles and won't be featured in the game, but I was just looking for this demo code to work with. Then there we've got the plot. So I wonder if this is the best format to keep it in, because I kind of like having the key as a string, but Symbols are just like such a common convention that I wonder if I would be better served by sticking with that. Whoa. Keys can have spaces. This is blowing my mind. Key with spaces. What? Oh, now it turned the. So now if we do that same thing, but we say like the, and access it like that. What? Oh. One more set of parens, perhaps. When in doubt, add more parens. The def tests. When in doubt, add more letters. So if we say like the test nil. What? Whoa, 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 whoa. No source file. Yeah, so I think we've learned that keyword works in kind of strange and mysterious ways. Even though it makes things like really easy in some respects when you're working with maps, I think maybe just sticking with strings for the keys for this map is going to be a good start, because then we're not going to run into that like crazy keyword stuff that we just saw. So anyway, movie titles. Yeah, so let's say like titles, game code, host, movies, movies, right. So I think what we want is like a random selection from here, and then we're going to create like a subset of those. And we already had that function up here, so let's just take that as well. Okay, get rand titles. It's going to be the title, but also like the movie description too, right? So we're going to say like get random movies. Get game code. Let's just call this get movies. All right. So we're gonna have a number of movies and a collection, or a map in this case. So we're gonna say take that many number from a shuffling of the movie keys. Yeah, so this will give us like a random set of like titles, but what I want is like the title and the description. So I think we're gonna embrace the REPL and try to develop it using the REPL. Okay. Yeah, so what I'm really interested in is like, can I shuffle a map? All right. I know you can use like list like functions in Clojure. You can use them on like strings in many cases and like maps in many cases. So I think I'm going to say like, oh, and here's a good opportunity to demonstrate that debugging technique I was talking about at the beginning of the stream. So we can say like def n2 def movies movie titles. Cool. So load that into the REPL, and then we're going to say get movies and movies. It's a Wonderful Life, Ghostbusters. Right, so we got a list back. And then if we get rid of this, what will it give us? It'll give us an error. Persistent array map cannot be cast to Java util collection. So my JavaScript brain wants to take this map, turn it into an array, shuffle the array, and turn it back into a map. But I wonder if we can do like randomize map key order closure. Select keys does not sound like the thing, but random function. Select keys. Return a map containing only those entries in the map whose keys and keys. Yeah, that's not what we want. Select keys. Yeah, actually it could be, right? Because we can like randomize the movie titles into a list of movie titles and then just call select keys on it. So that could actually be, yeah, that's a good way to do this. Right. So let's back up. Shuffle keys movies into the REPL. Call the code. Okay, so now we can get a random list of movie titles. Okay, this seems like a good opportunity for a threading operator to me. Yeah, we need to know if we're going to thread first or thread last. I think we're going to thread last, because we've already got the map. What we don't have is the key sequence. So let's just try it out. I've copied the code for threading many times, but I've only rarely actually written a threading function from scratch. So I'm gonna just put our leg like a little deeper into this language. We've got our foot submerged in the cold ocean water up to our ankles, and now we're gonna take another step and maybe get halfway up our calves. Okay. And first, we need to review the thread last macro to see how it works. Threads the expression through the forms, inserts X as the last item in the first form, making a list of it if it is not a list already. If there are more forms, inserts the first form as the last item in the second form, etc. I didn't understand that a bit, but hopefully we've got some good examples. Range. That's some more of that lazy evaluation stuff I was talking about before. Right. Macro expand. That'll be something I get into later, I'm sure. Ooh, threading. Hey, good morning, Cliff. How's it going, man? Threading is super cool. I don't know if you remember this from my live programming at E-Trade days, but frequently what I would do is demonstrate this function called pipe. So threading is like a very similar thing to piping in Lambda and JavaScript. So essentially what you've got is this like sequence of functions that you want to call on like either one or more arguments, like in sequence, one after the other. So like the first function like takes that argument or set of arguments, does something to it, then it passes that return value to the next function, which does what it's going to do, and then passes that value onto the next function. And because this one is last, it is the one that actually returns the value. So yeah, if we say like call this function with the numbers 3 and 4, first it's going to take 3 to the power of 4, turn it into a negative number, and increase it by 1. And that is also a concept of compose, which is like pipe but backwards. Well, actually, if you're talking about what's really going on under the covers, pipe is really a backwards compose when you're talking about the actual code that like gets run when this function's called. But anyway, yeah, compose is just like running those functions but backwards. So it's going to say classy greeting and then make it uppercase. Right. So threading is very similar. We've got this concept of like a thread last macro and a thread first macro. So this is like pipe, but and all the functions run in order from top to bottom, but thread first and thread last is like where the argument goes. Oh, thank you, man. Yeah, this is like my gateway drug to this language, is this library. It's like so many of the ideas in Ramda are just kind of like baked into Clojure or baked into Lisp in general. So that's the path that got me here. Yeah, you know what? It's good. It's a good opportunity to just like kind of practice with a goofy function first before I really get into it for real. So definitely add a lot. That's going to take a number. We're going to say thread first, the number +1, +2, +3. So I think this is going to pass n as like the first argument here. So if I were to pass like 4, for instance, that would be 4 + 1, and then the result of that gets passed into here. So that's like 5 + 2, and then that 7 gets passed in here, 7 + 3. So I think we're going to get 10 by the end of this function. So let's add it into the REPL. Let's say add a lot. What did we say? 4? 10, right. And then if we want to do like thread last and change these to subtraction minus signs, that'd be like 4 - 1, which is 3, or 1 - 4, which is -3, and 2 - -3, which is 1, and then 3 - 1, which is 2. So if we call this sir sub a lot, sir sub a lot for -2. Okay, so like yeah, not great at basic math evidently, but that's the general idea of what we're trying to do. So what we're trying to do here is get a random selection of movie titles and then like use this not this keyword thing, not this compose with thing. Before I forget, I'm trying to save a list of all the references I make when I'm doing these. So we're going to use like select keys in addition to this threading macro to get a random selection of movie titles from this map essentially. So let's see if I understand what I'm doing here. Okay, so I think we need thread last. And we need thread last because select keys expects the key sequence as the last argument. So we've got like a set of movie titles, then we've got our random set of movie titles, which we already know how to get. So I think all I need to do is then select keys, movies. I think that's it. Get movies and movies. Oh, hell yes. That was exactly what we needed to do. Oh, nice. Awesome. Let's call that one more time. I can't believe I got that right the first time. Oh, fantastic. Yes. Okay, so we got this list of 4 movies and we want to get 2 from it. So the first thing we did was we selected a random set of keys from this like movie map, this movie object. So here we've got a key and here we've got a value. So the 39 steps, the title and its plot, the aviator, key, and its plot value. So we got a random set of keys from that map, and then we selected those keys from movies using the select keys function. You know what, let's yeah, here we go. Okay, I wanted to get more into like REPL stuff, just like general REPL practice. So this is exactly what I'm looking to get out of this language. So here we have the result of the evaluation of like this part of the function, this form. So take and shuffle keys movies gives us like the 39 steps, Ghostbusters. We run it one more time. The Aviator, 39 steps. The 39 steps, It's a Wonderful Life, and then yeah, that is the list that we pass to select keys. This is our object. Select keys based off of our random set of keys will give us a new map based on the subset of the keys we asked for. So that is, it's nice. It's nice. I like that. Oh, we didn't even get that. Get a random, or hold on. We actually haven't done this thing yet. Add starter movies to the game state. So we're halfway in. We can get a random set of movies, but we haven't plugged it into the rest of our function just yet. All right. Movies, right. So we got this game state starter, which is building our map. And now we need to supply movies to it. So we're going to say get movies, 3 movie lists, movie titles. It's not really. Exactly what's in there. And yeah, we should have pretty much what we need. So let's clear this out. Let's load the code into the REPL. Let's create a game with a host of Cliff. All right, here we go. There's our random game code. Here's the object containing our game state. There's the host of our lovely game. And here is the random selection of movies, which we are going to, we're going to write fake plots for. So great. Nice. Awesome. Ah, man. Such a productive morning already. Hope I don't jinx it. Okay, cool. So what do we need to do after this? We've got the host. Oh, you know, we didn't add the players. So the host players is going to be a vector containing the host for now. Yeah, so let's see what that looks like. Host is Cliff, the players are Cliff. All right, great. And here we get into the part where we add the players. So we've essentially like made our game. We have a set of players, and that's what's gonna happen at our like register game WebSocket route. So we're going to register this game. It's going to give us back that object. We're going to send that object back to the front end eventually, which is going to become like the game lobby page, which we developed last week. And now we need a way to add players to this game. So yeah, what we need is register players to already created game. Cool. All right. Create game. Now we need a register players function. Register players. So we'll take some arguments and it'll do a thing. All right. So I think what we need for this is we need a player. We need a game code and we need game state. And we need a game to add them to. All right. And coming from a random background, I'm very keen on the idea of data last, which means that we already know what the game is, but the things that we don't know are who the player is and who the game code is. So yeah, that's something that like Randa enforces on you. Well, it doesn't enforce you, but really encourages you to like write in that way. But something Randa doesn't have is that like thread first and thread last macro. Like all it really has is like pipe, and the whole library is written around the idea that you call like these functions with like partial information, and then once you have like the final key which unlocks all the chain, like the whole chain, then you call them all, and that final key which unlocks the chain always comes as the last argument to the last function. So I suspect that's gonna help me here as I write this game, as I write this code out. So let's start with that assumption and see if it works. All right. Yeah, so we're gonna need to like take an existing game and update it, but then we also need to update the state along the way. So yeah, this is kind of like an effectful function, right? I guess this is an effectful function too. I think this has some like pure elements in it, in that we're building objects and passing values from like one function to the other, but we're also calling swap on the game state as well. So we may discover a better way to actually organize that so we can separate out the like effectful code from the non-effectful code, but we'll cross that bridge when we come to it, I suppose. All right, so register players. So I think we need a function called assoc_in. We had assoc open, so if we go to the docs for assoc_in, what do we find? Associates value in a nested associative structure, where keys is a sequence of keys and v is the new value, and returns a new nested structure. If any levels do not exist, hash maps will be created. So here we have a vector, or an array, or a list of objects, or maps. Can be used to update a mutable item. Person's Bob, age 11. Yeah, so this is what we're trying to do, right? Person's Bob, age. Yeah, so that's like adding a new key to an object, but really what we want to do is add like a new player to our lists. So maybe like a map function is really what we want. Fintroll. Haven't heard that name though in a long time. It's like a folk metal band. Yeah, so this is JavaScript. You'd push it in. Conj is what we want. Ooh, Coj. I love this. This is the creator of the language Rachiki. And when you try to go to a page that doesn't exist, you get a 404 page, and it's like a sad photo of Rich. That's so funny. Yeah, so we just want to conj onto an existing list of new value, right? But we do want to associate in because we're updating a nested object. All right. So we want to say assoc in the game. Okay. Assoc in the game at the index of the game code. A new array. Game code. It's like a game code and players. The result of conjing okay. So conj this thing with test. So this is just gonna like blow away everything in the player's vector with a vector that only has test. So let's see if that works. All right, let's use our handy debugging tools. A def game. That'll be nope. Okay. So first we'll say create game, the host of Andy, def game, game states, def player, Siri, def, we don't even know the game code yet. I'll say def game code is going to be like first keys game, I think. So what happens if we evaluate that? Oh, first we need to call this function, then we can call that function. Yeah, let's call register players with the game player and game code. I cannot believe I wrote that right. Oh man. Maybe I'm starting to get this. Maybe I'm like starting to understand the language. I think I might be. That's really exciting. Man, I've heard stories of people learning Clojure and saying like, oh, within weeks I was like, pretty productive with it. I never quite believed it, because there's a lot of concepts you really need to get into your head in order to like work effectively with this thing. But man, I can't believe I just wrote that function. That's wild. That's so cool. I've been programming this thing for like 2.5 weeks. That was like a fairly involved bit of code right there. There might be hope for me yet. All right. Yeah, so instead of test, we're going to conj player. Let's call that function again. Cool, so now Siri is a player, but we blew Andy away. So yeah, now we need to access that. So we're gonna conj I think we want to say like game. No, we want to say like players game code game. So yeah, we've got like this game object. And what we're saying is we want to access the game code. So we already know what that is, like FCSV in this like random example. So we're going to use the game code to access that value in games, and then once we have the result of that evaluation, we're going to access the players property in that object, and we're going to combine our new player onto that array. So let's load in. Yes. Nice. All right, so now we got players Andy and Siri. Let's try it one more time. Excellent. Great. Done. Well, actually, we're not done. Because we need to save that back into the game state. We've just returned the object, but we haven't saved the state yet. Let's erase that until we're finished. All right. Yeah, so now we got this. I feel like I want to thread again because that just like results in cleaner code when you can do it. Perfect. Alright, so now we have the question of thread last or thread first, and we need to figure out how to use this with swap. And do we need swap, or can we just use reset? Because swap will take a function, like an updating function, so whatever the result of calling that function is gets saved back into your atom, which is like a variable thing. And we've got reset, which will just like blow away whatever was in your atom with a new value. So here we created an atom called x, which was 10, and then we just reset that x atom to 20, and now the atom is 20. These freaking people just use the REPL to dereference the atom value and like get it straight away, but I couldn't do that. Yeah, I blew away the code already, but what the hell, man? What was going on there? Anyway, not important. Swap or reset. So let's think. Just see if, like, at the end of this thing we have create game register players. Right. So we have code which will only affect one specific game and we'll leave the others untouched. So I think we can use reset in that case, because like what we were saying is like our test game code is like just the first key in here. So we added Siri to a game created by Andy. We got a vector with Andy and Siri, but our other game created and hosted by the lovely C. Vince was not affected. So I think what we can do is we can just reset. I'd still like to use threading, and we're going to use reset. Okay. Threads the expression through the forms, inserts X as the last item. That's definitely what we want. So now instead of thread first, which we used, where did we use that? Did we use it at all? Did I imagine it? Ah, okay, so we used thread last up here, and we're going to use thread last again here as well. Okay. We're going to call that, and then we're going to reset game state. And secretly, the result of evaluating this is going to get passed in as the second and final argument to our reset function. But now it's telling us we've called with one arg and it expects two. I think we just had to wrap it in a form. All right. Cool. Register players. Can we say like add game states? We can't, I don't know why, but we can sure print line at game state and see if we've got it right. Alright, so here's our random game. Here are the players, Andy and Sari. Here's our other game created by C. Vince, and he is the only player. So, yep, we've got that all done. Man, light speed. Done. Already 11 o'clock, wow. It was like the first day, I feel like I'm really getting it. I'm like understanding this and like getting the benefits that I sought to obtain by choosing this language. So, man, I'm feeling really good right now. Register players. What comes after this? So you can register players, we can register multiple players, we can get a random set of titles and add those titles along with their descriptions into the game. Now I guess we need to get into actually like sending plots to players. Yeah. Yeah, because now we're getting into like actually going through the rounds of the game. So we've got like creating the game and adding the host as a player to that randomly created game. We've got adding players to that game so players can join the game. And now, once you've registered the game and joined the game, the next step after that is sending the plots out to the players themselves. So let's move on to that. Oh, plots to the players. All right. So this has some some things involved, right? Like, gosh, I really wish I could inspect this thing in the REPL. Closure pretty print. More goodly in a better way. Pprint. Can I just call that like straight away? Pprint. Nope, I need to require it. Require. Oop, rapid form. Require closure preprint as pp. So now if we do this, pretty print the game state. We didn't load it in. Really? Require closure pretty print as pp. Here's another unexplored thing about the REPL for me is how to get like a library in. Yeah, we could get off on a big tangent where, you know what, none of this is even relevant to what we're doing anymore, so how about we just get rid of it. Get ran titles, we're still calling that. Get movies. No, we're not even calling that anymore. We can get rid of our function from before. Okay. PP at game states. Can we do that? Able to resolve symbol PP? Read carefully the example code. PP/pretty prints. Okay. Yeah, so let's create a game again. Create game. Register players. That's XVQQ. Maybe it was really key after all. All right, cool. Yeah, so now we got that, and I think we can have a list of movies, and we can have like a list of rounds based off of this movie. It's like one thing I could do is I could just like kind of grab any old like random movie from here, like when a round comes up and say like, okay, it's round 2, now we're gonna get the Aviator. But then what I need to do is I need to keep track of like what movies have I sent out, which are like okay to take from this object, which aren't okay to take from this object, which if they played first, which have they like not already played. So I think what I want to make is like a oh, this is really nice. Just like editing this thing like straight in the REPL window. That's super nice. I think I want to say is like a rounds, game rounds. There's a better word for this somewhere. Game round titles. Ghostbusters, The Aviator. And we'll just put this at the front to kind of simulate what I'm talking about here. So what we're shooting to do is we're shooting to like write a function which is going to get like random titles from our movies. Like this is just going to be like the movies we're working with, and then we'll like never touch it really. And then each time we have a game round, we're going to just like pick the appropriate index from this vector and then send that to the players. Game round titles, game ordered game plots. Ordered game plots, yeah, sure. Yeah, we'll go with that. If anyone has a better idea for this concept I'm trying to think of, then feel free to chime in the chat. But we'll just choose that name for now, and maybe we'll come up with a better one later. Okay. So that's what we want, and how do we get there? I think we get there when we're creating the game. Yeah, so if we create the game, we have this like game state starter, which gives us a set of movies, which is how it makes it into the object, into the map. Excuse me, terminology. Now we need this ordered game plots. And that's going to be evaluation of, we already got the function up here. Let's just copy that. Yes. Shuffle keys, movies. Alright, so that's referencing like this map up here, which is like all of our movies, which is why we're getting like all 4 of them every time. But I think when we run this, like for real, we'll have exactly what we want. Alright, let's keep things simple. Here's our like little game bootstrapper code. Register players. Game code at game states. Game code seri. First keys, game states. Where are we getting this? Line 49. Game state. Oh. Wrong order of the functions. Arguments to the functions, rather. Line 51. pp/p print. Excellent. Ghostbusters, It's Wonderful Life. Aviator, Ghostbusters, It's Wonderful Life. It's Wonderful Life, The Aviator, 39 Steps. That's exactly what we want. Excellent. Nice. Alright, so now we've got an ordered game plot. And now... that was the first part of what we were trying to do. The second part of what we're trying to do. Create a random vector of game plots. Now we just need to like pick the appropriate plot depending on what round it is. So get the appropriate plot according to round index. All right, now we write that function. So defin get round title, get round plot, and we need like a game code and a round index, and this is just going to be add game states. Game code at game states. So yeah, this is going to be the code CETM, and that's how you access a key in a map. You just pass it the map that gets the value, and right, the next thing we want to get is ordered game plots. And from that, we wish to obtain the index, the vector of that index. So say we had, so say we've quit VS Code. Right, I think I need to, Command A, not Command Q. Wrong lever. Alright, so let's start Calva again. Close your CLI. Alright. So if we had like a def vector of A, B, and C, we want to say like one vector. Is that what I'm looking for? Nope. Access vector by index closure. Get. get or nth. Indexed access. Oh, it's just backwards from how I was doing it before. Yeah, so we can use that. We can use nth. That's specifically for a collection. Returns nil if index is out of bounds. Yeah, I guess we could use get. It seems like more of a like general purpose kind of thing. But let's use nth. This is cool. This is like a default value if you are trying to access something that doesn't exist, or which is like outside the bounds of what the vector actually contains. So that's really cool. Haven't had a need for that yet, but I'm sure I will. Yeah, so if we say like nth vector 0, 9. A, right. Okay, so that's what we want. Yeah, nth. And index. Yep. So we're getting the game from the game state. We are finding and sorting game plots, and we are choosing the index according to our round. And just so we're not like reaching up into game state. Just so we're not reaching up into the global scope to like grab that thing. Let's be good little functional programmers and pass it as an argument. Right, so now we just say get round plot. At game state, game code, and yeah, let's start with the first one. Don't need that. Ghostbusters. The Aviator. Well, actually, let's pretty print just to make sure we're actually getting what we think we're getting, but I'm fairly sure that we are. Alright, cool. So we're trying to get the first one from our order game plots, and we are. Let's try to get number 1 from that same state. 39 steps. There's number 1. There's number 2. It's a Wonderful Life. Very good. And number 4. Execution error. It could be interesting to do some kind of default value, but let's not get too deep into that. All right. Wow. Yeah. Lightning fast. I'm so much farther than I thought I'd be. Create a random vector of game plots. Done. Get the appropriate plot according to the round index. Also done. Great. Okay, we need some more stuff. Let's just keep chugging, ladies and gentlemen. Yeah, so let's think about the flow we have. We have registered game, we have added players, we have sent out plots to the players according to the index of the round they're on. So we've sent out the plots, but now we also need to send out like the real plots. So get round title. Yeah, so it's not really a plot that we wrote. We wrote a get round title. So now we need to do the same thing, but for the plots themselves, because eventually we're going to end up in a round of the game where everybody's like fake plots are mixed in with like the real plot, and the whole point of the game is like, okay, you wrote like fake plots to try to deceive your friends about like what this movie's about, and you have to vote for like what you think the real plot is going to be. So let's move on to that. So get round title, define gets round plots. So that's going to take all the exact same stuff. You know what? I think I can actually call get round title. Because, yeah, we need like the title, and that's going to give us the key with which we can access plots inside this movies map. I think that's how I want to do it. But where would you do that? So get round title. Yeah, we can use that. We can use that get function that we were looking at before. So we're going to use get. Our map is going to be our movies, and our key is going to be whatever our ordered game plots at like the round index is going to be. So we're going to go back into ordered game plots. We're going to find whatever the title is at round 1, round 2, round 3, and yeah, we're going to use that to access our movie. So get and maybe this is like nth round title. So we're getting the title according to whatever round we're on. So get nth round title. Wrap that in a form. Game state, game code, round index. Yeah, now we need to get from the game state we need like a get in, I think it's going to be called. Yep, get in. I'm even get more familiar with the naming conventions for all these functions. So get in profile name. That's going to like kind of sequentially dot into some kind of nested data structure. So that's how we're going to get the movies. So get in game states, game code, movies. Let's call this nth round plot. At game states, game code 2. Load that into the REPL and run it. Nil. No, what do we do? So we can get that, can't get that. Alright. We've written a bug, and one of my goals today is to get better at debugging with the REPL. So let's take another opportunity to do that. Although I think I've already found my bug, right? No, I haven't. Ghostbusters and nil. Alright. Alright, so let's like break this into lines, right? So we're calling get in. I think I already discovered the bug. Yep. 39 steps. Man, London tries to help a county espionage agent. So let's say like round 1. The aviator, billionaire aviator, round 0. Ghostbusters, 3 eyeball scientists. Excellent. All right, we've got our title and our plot. All right. I think I like how that's indented. That looks nice. Great. I can't believe I've written this in like 60 lines of code. And that includes like all this kind of bootstrappy, like hard-coded stuff up here too. That is yet another reason to be enamored with the language. You can say a lot with very little. Great. 1124, what else can I get done? I can clean up a little bit. Oh, I can quit VS Code once more. Accidentally. Alright, great. So let's clear this out. Start Calvo once more. And let's think about what else we can write. Alright, send out the plots to the players. Next thing we need to do is register votes. So now we've gotten to the point of the game where you're looking at your plots that the players have written mixed in with the real plot, and you need to vote for the one that you think is the real one. So, yeah. You know, I think I skipped a step, because, like, yeah, we can send out, like, the real stuff to the players, but what we didn't do was, like, collect the plots they've actually written, right? Like, we haven't given players a method to, like, actually add their own plot to the game state. So let's run this one more time and think about where we would do that. So we got the players ordered game plots. Really like a better name for that, but we'll stick with it for now. Easy enough to change, isn't it? And now we need plots. So this is going to be... I could do this like round one. And we could have like Andy was dark and stormy. And we could have Sari. It was the best of times. So we could do it like this. Just objects and keys for everything. Or we could do it like this, where, like, we've got this kind of game which implies a data structure of a list, and, you know, Lisp. If we head to the wiki, stands for lists processor. So anyway, the whole like ethos of this language is like everything's an array, right? Like everything's a list, everything is something you can operate sequentially on. So if we were going to do this in like a Lispy fashion, we would turn this into a vector, and we would say like each object in this vector is around. And then we would say like Andy was dark and stormy. Then Sari would say it was the best of times. So we could do it like that, and that would be more in keeping with the like general concept of what we're working with. And I think that's what we should do. So this looks like just a lot cleaner and easier to work with. So instead of going with like a map and keys and all that and having to like invent keys along the way and really using the keys in kind of a ordered and indexed fashion, we will go with this. All right. So yeah, we need a way for send out plots to the players. Let's see. Method for players to add plots to game state. Great. Yeah, we'll call this defin submits plots. So this is going to take all the usual stuff: game states, game code, player and their plots. Easy enough. But you know what? We need a round. Yeah, so do we send that along with the function, or do we just track that in the game state itself? Because we can also have, like, the concept of a round index. And that'll be, like, 0 for the first round, 1 for the second round, 2 for the third round. So We could track that in the game state, or we could just like have that be the responsibility of the caller of this function to supply. Spider Sense telling me it's going to be better to keep this in the game state. So, yeah, let's track the round the game in game states. Yeah, so we want to keep track of where the round is. So that involves round initializing that to 0, and we also need a way to increment. Initialize to 0. Pretty easy, right? Not much to it. Increments by 1 each round. Okay. Let's see. So that's like a different increments round. That's going to just take game states. So we're going to say assoc in game states. Yeah, so this will like return the game state with the round incremented, but I think we also want to set the state as well in this function. So reset game state with the result of associating in the game state. Let's just go back to the docs to make sure we know how to do this. I think what I really want is assoc in. Yeah, what I want is assoc in. Assoc. Assoc in game state. Game code. Round index. The result of incrementing. Let's try let block. Let's try let block here. Let's no, let's not do that. Reset the game state with the results of calling this function. So we're associating the game state at the index of the game code at the round index. Was it get in? Yeah. Increments get in game states game code round index. Have I written this? We've come much farther than we thought we would, so yeah, how about we experiment a little bit? So one area I can see to improve is like this. So this is essentially like, you can think of it like a vector. I mean, in other languages, like specifically what I'm thinking of is JavaScript. You'd have like a const obj, and this would have like a nested value of some string. And so, I'm already losing my skills. And we've already defined an object constant. No, we haven't. All right, so this would be like obj dot nested dot value. So soch in is essentially like repeatedly dotting in. Cliff said, lost some progress today. Off to live stream the inauguration. Yeah, exactly. Man, I'm heading straight there afterwards too. So anyway, I'll join you there in spirit. Yeah, man, crazy time. It's crazy time in this world. Actually, live streaming the creation of this game is been a really good way to escape that. But yeah, we're getting back into it. So anyway, get in. Oh, thanks for joining the stream, Cliff. I'll see you later. Get in is essentially giving us this functionality where we can like dot into a nested value, and so that's like dot this, dot that. But really, the way you access that is through the syntax of a vector. So we could just like save this vector as like a let variable. Let's we need this on the block, right? Round index accessor, have this variable. Now we need to put this in the scope. That's why you can't miss a show. There we go. Reset the game states at the round. Yeah, will this work? So if we had like a yeah, let's just try like increments round and game state game. Let's see if this works. Of course, we got an error, and of course, it was related to that function. All right. So let's learn how to do this. So we defined a vector, which is like what we want to pass to a search in. I feel like what we want is apply. Apply to this function those arguments. So this is already getting too weird. I think this is like a skill I will obtain later, but this is like too much too fast. Keep it simple. All right. Pretty sure this will work, so let's try. Increment round game state game code. Then we will pretty print the game state, and it should be 1. Nope. All right, 63. So we still got a problem. All right, game state, game code, round index. Right. So we need to know what to increment it up from. Now the question becomes game code. Oh, no, we don't. Increment round. Game state, game code. So what was the deal? increment get in game code. Right. I wonder if we have access to this right now. We do. Can we inspect game state at the index of game code round index? What will this give us? Closure lang atom cannot be cast to closure lang I function. Oh. Get in the car. Nil. Get in game state. Game code round index. Game code round index. Why are you nil? Get in game state. The game code and the round index. There's something about get in that I don't understand. Profile name. I sure think I've got that right. Get in game state nil. What if we just use the real thing? Right. Okay, so we didn't have the variable that we were trying to access. Round index. Right. So we're starting at 0. So the problem is like here. Yeah, associate game states, so we know how to get there. We know associate is the thing we want to use, but now TNLC. So what does this look like? Yeah, so it increments it to 1. So we got the code right, which like actually increments the round, but I think what we've not done is written this. To the age of the second user, 1 age 44. Associate in the game state the index of the game code and the round index. The result of incrementing. I wonder what I'm doing. Round index. Increment round. Game state, game code. Well, what's the error? Persistent array map. So the problem is, I think, the like atom resetting thing we're trying to do. So if we just say like increment round and turn that into like a pure function, what does that give us? Right, so that'll increment the round index. Right, it's still 1 because we're just returning the mutated game index. We're not actually resetting it. So yeah, the problem lies in actually changing the value of this game state atom. Reset the game states. Let's head back to the reset docs. Sets the value of the atom to new val without regard for the current value. Returns new val. Resets this thing with the result of calling that function. I'm missing the piece somewhere here, man. I don't know what the piece is. Yeah, it's 11:45. We got 15 minutes to figure it out. I think we can. Reset in the game state. What if we like something weird? What if we just do that? Alright, so there's a clue. 52. We tried to reset our game state to something totally bizarre and it didn't work. At game state, what is it right now? What if we did like pretty prints, p prints result of resetting the game state to something totally ridiculous? It's because I'm trying to dereference my null pointer. Dereference a null pointer. Which makes me think about this.
Come on, you guys. There it is, right there in front of you the whole time. You're dereferencing a null pointer. Open your eyes.
I love that. I don't understand it, but I love it. Dereferencing. So the problem was that we were trying to pass the dereferenced game state value to increment round as opposed to just the raw atom itself. I don't really know what I'm talking about here, but yeah. So we'd written that function perfectly. It was just a matter of passing the right thing in the right way. So we got rid of this. Get rid of our debug code. Get rid of our comments. We button it up a little nicer. We load it into the REPL and we see 65. We see that we have a syntax error. On 65. Register players. Hold on. Register players, add game states, Seri game code. What? Here I was resetting it. Oh, you know what? I was resetting the game state itself globally as opposed to the game that I actually passed it into. So I bet if I change this to that, I would start to get errors that I haven't had before. Yep. Okay, so this problem is sleeping in many areas of our code, and we might have goofed. We might have goofed a little bit. $65. is obviously not it. Increment round. Reset the global value of game state. There we go. So now we've incremented the round successfully, having fixed our syntax errors. But I think in these last 10 minutes, what I want to do is I want to... This will be a good thing to look up later, or maybe someone can email me at... right, so we got this done. Refactor state-ish. Can I do this better? Email me at andy@startupinamonth.net. So there's my email address. Please feel free to reach out to me if you can imagine a better way to do this, or comment on a YouTube video or something like that. But anyway, what we've got going on is the following. I have got some functions which take a game, which is this game state thing, which is an atom. And atoms are like special things which kind of keep track of like variable information that like mutates in your program over time, but it gives you these nice methods to like update it in orderly fashion, and it also gives you the special syntax for like passing in the value of an atom dereferenced from the atom, whatever that is, whatever that means. So anyway, what I've been doing is I have been passing in that dereferenced atom state into my functions. So if we go into register players, we have like game, and we're doing all the transformations on like those data structures that we need in order to make the changes to the game state that we need. And then we're calling this reset function on the game state itself. So within this function, we're calling this thing, which is like kind of reaching outside the function and mutating the global state. And that's generally something you want to avoid in like a functional programming context, because the whole idea of like functional programming, which is the basis for the Clojure language in general, is like pure data in, pure data out. Don't mutate unless you absolutely need to, and keep your mutations on the fringes of your program, like not bound inside your app like I have it currently. So not sure what is best to do here. Should I call reset on the global atom variable from within the functions, or should I do something like reset the game? Or should I do something like passing in that value of the atom directly into the function and operating on that function argument? Now, all my functions pass in the dereferenced value so far and update the global game state from within those functions, so I think I'll keep it like that from now on, or for the time being anyway. But how about we clean up our issue a little bit? Search in the game at that index, result of calling this function, and then reset the game state. Method for players to add plots to game state. I think this is a pretty good stopping point. So, yeah, man, I mean, I think this has been my most productive day of the entire thing thus far. We got as far as like, I got most of the game done. What we need to do, we need method for players to add plots to the game states. Method for players to vote. I think we need a method for the game to request state, votes, plots, players, rounds, etc. And yeah, we need a method to figure out who won. So yeah, we're kind of coming to the final stages of this game, right? Like, we need a way to add plots to the game. So that was this thing I was doing up here, which I think I probably blew away, or did I? Yeah, so we need this thing. We need a way for players to like add plots for like each individual round, which is going to be a series of maps within a vector. We need a way to track votes for each round. And yeah, based on the votes, we can write a simple function to tally them up and determine a winner. And yeah, after that, you've got a game, ladies and gentlemen. So anyway, that's where we'll start for now. And yeah, thanks for joining me. Real excited about the progress we made so far. This is really shaping up in some nice ways. And yeah, I feel like I unlocked the key today. I feel like I felt comfortable writing this code. It felt natural. It felt good. So yeah, I'm real grateful for that. Thanks for coming along for the ride, and yeah, we'll see you tomorrow. So I'm off to go watch the inauguration. Whoa.